Hello dear students, I am Professor Shraddha Firke from the KK Wag Arts, Commerce Science and Computer Science College, Kaka Saheb Nagar, Ranwad. Today we are going to study a bubble sort algorithm. To study bubble sort algorithm, first we have to study what is a sorting. The sorting is a method of arranging or ordering the records of the elements of the table in a logical, that is alphabetically, or in a numerical order, that is ascending or descending order. Sorting algorithms has different algorithms. In that we will study bubble sort algorithm. To study bubble sort algorithm, first we have to study the working of the bubble sort algorithm. Suppose we have the list of numbers like a1, a2 up to an in our memory. So the bubble sort algorithm works as follows. In a step 1, first we will compare a1 and a2 and arrange them in our desired order, so that if we have to arrange the elements in a ascending order, then we will compare a1 and a2. Let's say a1 is less than a2. Then we will compare next two elements a2 and a3 and arrange them also, and this will be continued up to an minus 1 with an. So we will arrange all of them in our desired order. If a1 is less than a2, then we will keep them as it is, and if a1 is greater than a2, then we will swap the both of elements. So when this step 1 will be completed, the an, that is last number, will be the largest element from the list, and this all process is called as a pass 1. Then step 2, we will repeat this step 1 with 1 less each time. That is, at every pass we will get the largest element from the list as a last element. So we will compare and possibly rearrange the an minus 1 and an minus 2 and an minus 1, and after the n minus 1 steps, the list will be sorted in our increasing order. So we will note here that accordingly the bubble sort algorithm requires n minus 1 passes, where the n is the number of input items. If the list contain n elements in, so let's say numbers, then we will require n minus 1 passes. We will see some example. Let's sort the given elements by using the bubble sort, and the given elements are 5, 12, 3, 9 and 16. These elements are in unsorted way, unsorted list. So we will sort them using bubble sort. For that we will consider first pass 1. In a pass 1, first we will write it down the elements in a given order, and then compare first two elements, that is 5 and 12. After comparing, we will see that 5 is less than 12, so there is no need of swapping. Okay, next we will compare 12 and 3, that is next two elements. Now here 12 is greater than 3, so we have to swap the both elements. So after swapping, we will get the numbers like 5, 3, 12, 9 and 16. Now in this list we will now compare 12 and 9. Here the 12 is greater than 9, so we have to swap both of elements. We are swapping these two elements because we have to arrange these elements in a ascending order, that is lesser element is first and then greater element. So after swapping, we got the numbers like 5, 3, 9, 12 and 16. And now for the last time we will compare 12 and 16. Now here 12 is already lesser than 16, so there is no need of swapping. Okay, so this is all about a pass 1. So after pass 1 we get 16, which is the largest element from the list. We got one last element, which is the largest one. Now go to next, pass 2. Now we got these elements in pass 1. This is the list. Now we will again follow the step 1. That is, we will again compare first two elements 5 and 3. Now here 5 is greater than 3, so we have to swap the both elements. After swapping, we got 3, 5, 9, 12 and 16. Now we will compare 5 and 9, and already 16 is a largest, so we will not consider that element. 5 and 9, after comparing, 5 is lesser than 9, so we do not want any swapping. Now next time we will compare 9 and 12. Here also 9 is lesser than 12, so there is no need of swapping. So after pass 2, we got a second largest element, that is 12. Then go in a pass 3. In a pass 3, we got the numbers like 3, 5, 9, 12 and 16. Here we will compare first two elements 3 and 5. Here 3 is already lesser than 5, so there is no need of swapping. After we will compare the 5 and 9. Here also 5 is less than 9, so there is no need of swapping. Then we got the third largest element, that is 9. At this pass we got third largest element. Okay, now we will go to a pass 4. Now this is the final pass, that is last pass. Here we got 3, 5, 9, 12 and 16, from which 3 and 5 are compared. Again 3 is also lesser than 5, so there is no need of swapping, and 9, 12 and 16 are already got the positions in a list. So at this stage we have got the fourth largest element, that is 5. So after this we got the sorted elements, that is 3, 5, 9, 12 and 16. These are the sorted elements from the given list. We have sorted them in ascending order, that is lesser number first and the largest number is at the end of the list. Now this is the bubble sort algorithm. Let's say we will see the total number of comparisons in a bubble sort are n into n minus 1 by 2. How we got this? N minus 1 plus n minus 2 plus n minus 3 up to 1, then which is equal to n into n minus 1 by 2. Now we will see the time complexity of the bubble sort. Each sorting algorithm has a different complexity, time complexity. Time complexity is the total amount of time taken by the program to execute in is the time complexity. The time complexity has three different time complexities. First we will see what is the worst case complexity. Worst case complexity of the bubble sort algorithm is big O of n square. Big O is the notation used for time complexities to show the time complexity. Now when the worst case complexity occurs, if we want to sort the numbers in ascending order but the array is in descending order, so then the worst case occurs. So if we got the numbers which are already in a descending order, so in each pass we have to compare the elements and we have to rearrange the elements, so that will be the worst case for the bubble sort. So the complexity will be big O of n square. Now we will see what is the best case complexity. It is a big O of n. If the array is already sorted, then we got the best case, that is big O of n. And what is the average case complexity? It is also big O of n square. It occurs when the elements of the array are in a jumbled order, that is not in a sorted order or not in a descending order, that is a jumbled order, as we seen in the above example. So this is the time complexities of the bubble sort algorithm. Now let's see what are the advantages of the bubble sort algorithm. It is a simplest algorithm. It is a simple sorting method. Again, there is no additional data structures that are required for the bubble sort. Now, what are the disadvantages? Disadvantages are that it is a very inefficient method with complexity big O of n square. Big O of n square is the highest complexity, that is insufficient method. Then even if the elements are in a sorted order, that is in a best case, all n-1 passes will be done. We have to sort them again. So that is the disadvantage of the bubble sort. Thank you.